Hi, 5th grade. This is Mrs. Gilka with your flipped math lesson for today, 8-8. Today's objective is I can translate word phrases into algebraic expressions. So we are going back to what we first started with topic 8, is learning how to just write down algebraic expressions. So here's our first practice problem. What expression shows the weight of the nuts after the weight of the jar is subtracted? So you can see over here I have a picture of a jar with some nuts in it, and the jar equals 4 ounces. So my job is to write an algebraic expression that shows how much weight the jar has. So I would be using a letter to represent how much the weight of the jar or weight of the nuts is, and I'm going to subtract the weight of the jar, and that's going to be the algebraic expression which shows how much the nuts weigh, because I've got the jar plus the nuts, and that weighs a certain amount. I don't know how much, but if I take the amount of it minus 4 ounces, then that's going to equal the weight of the nuts. This is an algebraic expression. So here's a definition of an algebraic expression. An algebraic expression is a mathematical phrase involving variables, numbers, and operations. Okay, so it has to have a variable like a letter, like a V or a B or a Q. It doesn't really matter. It has to have numbers like 1, 2, 3, and so on. And it has to have an operation like plus sign, minus sign, multiplication, or division. It has to have all 3 to be an algebraic expression. So looking back at mine, I see I have a variable, I have an operation, and I have a number. This is an algebraic expression. Okay? So, well, what is the algebraic expression for these word phrases? So I have my first phrase here, a number plus 4. The algebraic expression for a number plus 4 would just be a variable. I'm just going to use n for these. Plus 4. N plus 4. Easy enough, right? A number minus 4. That would be n or any other variable minus 4. 4 times a number. I could write 4 times n. Remember, with multiplication we have some choices. Or I could write 4n. Okay, we would not ever write n4. Okay, that would not be how we write it, but we would write 4n. I don't know why it is that way, it just is that way. Okay, and then a number divided by 4 would be n divided by 4. Or you could write it with n inside the division box, and 4 is the divisor. Okay, you could also write it as, I'll make another comma here, n divided by 4 would be n over 4. Okay? So let's practice. So you're going to have some word phrases, and we're going to change them into algebraic expressions. So number 1, twice the number of people. And I'm looking for words that are hints for what the operation is. Twice the number means it's times 2. Okay, of people. And to make it an algebraic expression, I'm going to have a letter in there. So my variable p times 2, or I could put 2p. Okay, either one of those works. Number 2, $7 less than the current price. Okay, I'm looking for my clues in here that tell me what operation to use, and I know that less than is the operation, or is a clue for subtraction. So $7 less than the current price. So if it's 7 less, then I know I'm subtracting 7 from the current price, and I'm going to use the variable p for that as well. Okay, so p minus $7. Number 3, 8 more gumballs than Olivia has. So I'm going to look for my words that give me a clue to my operation, and I see the word more, so I know I'm going to add. I'm adding 8. To whatever we already have, and Olivia has 8 gumballs, so I'm going to put A plus 8, A for Olivia, plus 8, and that'll equal 8 more gumballs than Olivia already has. Number 4, a number of students divided into 2 teams. So I'm looking for words that give me a clue. There's a big clue right there, divided. Now I'm going to use division, divide it into two teams, so I'm going to be divided by 2. And number of students, I'll use the variable s. So I've got my number of students, s, divided into 2 teams. Number 5, what would the expression, I erased some words there. What would the expression for the weight of the mixed nuts, I'm missing a lot of words there. The mixed nuts be if the weight of the jar was 8 ounces. Okay, so what if the jar was 8 ounces? How much would the weight, or how would you find the weight of the nuts? What would the algebraic expression be? Well, we'd have the weight of the whole thing, so I might use the variable w, minus 8, and that would give me the weight of just the nuts. Okay, so that would be the, all right. Number 6, it's the last one we're going to do together. I'm going to have you do a few on your own. Translate this algebraic expression into words. So we're going to do it the other way around. Now we've got the expression 25 and then multiplication symbol and then p. How would you translate that into words? Well, you could say 25 times a number, or you might say a number times 25. Okay, both of those would work, or 25 multiplied times a number. Either of those would work. All right, it's your turn. Let's see how you do. So you're going to translate the first few problems into words. So number 7, translate this algebraic expression into words. So we have a 9 plus symbol and or n plus symbol and a 9. Okay, so if you wrote down a number plus 9, or 9 more than a number, either of those would work. If you have a different way of writing it and you're not quite sure if that would be right, check with me tomorrow and we'll see if you got it right. Number 8, translate this into words. Okay, your answer should be something like a number divided by 12 or a number divided into 12 groups. Number 9, translate this algebraic expression into words. Okay, it should say something similar to 4 less than a number or a number minus 4. Okay, either of those would work. Let's try another one. Translate this expression into words. Okay, so your answer might be a number times 8, or it could be the product of 8 times a number. Okay, either of those would work. So this time you're going to write an algebraic expression. Okay, so number 11, write the algebraic expression for this sentence or this written expression. Subtract a number from 10. Okay, let's do number 11. Write an algebraic expression. So this time you have the written expression. You're going to write it as an algebraic expression using variables, numbers, and an operation. So number 11, subtract a number from 10. What would that look like? Okay, so you would have a number from 10. From 10 means that you're subtracting a number from 10. So 10 is going to go in front and subtracting a number, so you could use a variable n. You could use any sort of variable. It doesn't have to be n, it could be any other letter, but it should look like 10 minus n. Okay, so this one is tricky. Remember, because you're subtracting a number that tells you what's coming at the end, not what's coming at the beginning, even though it's the beginning of the sentence. Number 12, the product of a 9 and a number. Okay, so if you wrote down a 9 times a number, like n, again, you can use any variable. It doesn't have to be n. It could look like that. It could look like 9 or n times 9, that could also be true, or you could write n or 9n. Okay, any of those all work. Number 13, add 6 to a number. Okay, so it's telling us to add 6 to the number. So the number comes first, the variable comes first. N plus 6. It wouldn't be the other way around necessarily. 6 plus n, it would be n plus 6. Number 14. 6 divided by a number. Okay, the algebraic expression for this would be 6 divided by n, a number, or you could write it in the box, 6, in a division box, 6 divided by n, the number, or you could write it as a fraction, 6 divided by n. Okay, all three of those work. Number 15, the quotient of a number in 8. This one's tricky. The quotient of a number in 8. Okay, I'm going to be honest, 5th grade, I don't like the way that this problem is worded, because when they say a number in 8, I'm not exactly sure what should be the divisor and what should be the dividend. But this is a problem from our book, and if it's a problem in our book, it could potentially be a problem on a test. So I wanted to include this one, even though I think it's written badly, so that you'll know what it's asking you to do. So this one is asking us the same thing, the quotient of a number. The quotient means that we're dividing, so we're finding the answer of a number in 8. So a number divided by 8. So n would be the number divided by 8. So you could write it like that. You could write it in the box, division box, n divided by 8. You could write it as a fraction, n divided by 8. Okay? Number 16. This one's a word problem. Let's see if you can figure out the algebraic expression. You and 3 of your friends are going to share a candy bar. Write an algebraic expression to show the situation. Okay, so it's you and 3 of your friends, so that means there's 4 people. You're sharing the candy bar. We don't know how big the candy bar is or how much it is. But so we could use C as the candy bar, and you're dividing the candy bar between 4 people, you plus 3 of your friends. So it would be C divided by 4. You could do C divided by 4. You could do C divided by 4 like a fraction. Okay? And of course you can use any other letter besides C. I just use C for candy bar. Number 17. A person has to be 48 inches tall to ride a roller coaster. Jill, who is 12 years old, is taller than 48 inches. Write an expression that shows Jill's height. Okay, so this one is a little bit tricky. It's asking you to write an expression that shows Jill's height. Okay, and we know that she is taller than 48 inches. This part right here where it tells you that she's 12 years old, that is not important information. They're trying to trick you by adding extra information in there. They're trying to trick you by telling you who she is. None of that is important. But it is important that she's taller than 48 inches. So Jill's height right now is 48 plus however tall she's grown. And I'll put T for however tall she is right now. Whatever it is, it's going to be 48 plus T. Okay, so that's the expression to show how tall she is now. Alright guys, we are finished for today. Thank you so much. Have a good night, and I'll see you when I see you. Bye-bye.